Hello class, this is CSE 4410, sections 1 and 2, week 11, spring 2025. Alright, so we're gonna start looking into making a project in Unreal. So we're going to make a top-down game. So, when you open the Unreal editor, you'll be presented with this window here. You want to click on Games, select Top Down, select C++, give your project a suitable name. We're gonna call it Pangea. Make sure you spell Pangea correctly and consistently throughout your project. There's like 2 different spellings. Well, there's like 2 or 3 different spellings of Pangea. Don't be like me where I have it in the slides as Pangea spelled P-A-N-G-A-E-A in the text of the slides, but P-A-N-G-E-A in the screenshots. Yeah, don't be like me where I do it like that. Just be consistent with how you spell Pangea. Select a suitable location for your project folder. Now, I have to make the same project several times over, once for making the slides, and then once more for recording purposes. So, for me, I'm gonna place it under a folder called Recording Projects, and that's just because I have to make the same game at least twice. Anyway, with all that, let's click Create, and we're going to create our project file, our project folder. This is going to include a few pre-generated C++ classes. And it's also going to open up Visual Studio because we're going to need that in a few steps. We are going to write a few base classes. No, we're going to write a few derived classes that inherits from certain base classes, and we're going to use these in successive chapters where we really flesh out our game. Okay? Alright, so give this time to load, and while that loads, let's talk a little bit about the different base classes that there are in... Okay, there's Visual Studio. Actually, I don't need Visual Studio right now. I just want to talk about the different classes that are a part of Unreal. So, there are several classes. The first one we're gonna be working with is called A-Actor. A-Actor is for game objects that are to be spawned or generated in the world, such as projectiles or defense towers. There is another class called A-Character that inherits from a class called A-Pawn, which then inherits from A-Actor. As a naming convention, anything that inherits from A-Actor must be prefixed with a capital A. So A-Pawn, A-Character, they all inherit from A-Actor. So, that's actually going to be one of our first classes that we make. So, now that we have Unreal Engine editor opened up, and along with Visual Studio, we can begin with creating our first derived class. That is the defense tower. This class will be used to place a defense tower on the map. It fires projectiles at the player if they're within range. The tower has life points. The player can attack the tower, and if the tower's life points reaches 0, the tower is destroyed. Also, there is a countdown timer that limits how fast the tower can fire at the player. So, with that, in the content browser here, you want to go to C++ classes and open up the folder that has the C++ written on it. Here it's called Pangea, and notice that there are 3 classes here written already. Let's add one more. So click in the empty space here, click New C++ Class. Because the defense tower inherits from the actor class, we have to select the actor class. Actor is the base class for an object that can be placed or spawned in a level. Click next. We're gonna name this Defense Tower. No spaces allowed. And if you add spaces, it'll say your class name may not contain a space. So, create class. And now in Visual Studio, we have DefenseTower.cpp and DefenseTower.h. I'm gonna drag this tab and put it on the right of DefenseTower.cpp. Okay, so one other thing that's happening right now is Unreal is rebuilding the entire project. So this is something that happens, but you can also do this automatically. Anytime that you add, remove, or change classes to your project, you have to recompile it. There is a recompile button down here. It looks like a stack of blocks with a few blocks flying off to the side. Click that to recompile your project files. That way, all of the classes that you have added, removed, or changed will be recognized by the editor. Now that we've done that, we can go back to this. The project Pangea has been modified inside the project. Reload. Okay. Now, let's take this tab here and put it to the right of our DefenseTower.cpp. Now we have CPP files to the left, header files to the right. Let's expand this tab because we need to add a few variables and functions to this. So, by the way, where would you find this in the Visual Studio solution hierarchy? Go to Games and find the Pangea folder here. I don't think that's a folder though, but we need to expand this folder here. Look for source, look for Pangea again, and within this folder, there are CPP and header files for all the classes in our game. We have just made Defense Tower just now, so we have DefenseTower.cpp and DefenseTower.h. We also have headers and classes for. We also have headers and CPP files for other classes that were pre-generated when this project was made. We'll talk about those. We'll talk about those classes in a little bit. For now, let's go to the DefenseTower.h file and we'll add a few variables under the public section here. So this public section, you'll notice that there are two of them. One is for so one of these is for our variables, and the other one is for functions. So let's just keep it organized like that. So here we'll add 4 public variables. The first one is health points. Pretty simple. That's the player's health. We'll add it. Actually, no, that's the tower's health. The player also has life points, but we haven't written to the player yet. So for now, let's add health points. Shell. Defense, we'll set that to 2. Float. Attack. Range, we'll set that to 15.0f. Basically, how far can the tower detect the player? Finally, float, reload, interval, and set that to 1.0f. Alright, now we have 4 variables in here. Let's add a few more variables in the protected section here. The first one is int, and it's also called health points, but it's prefixed with an underscore, so underscore health points. This is the tower's current health points. So this is how many health points the tower can have. This is the health points the tower currently has. Next, we're going to add float reload. Reload counting down. So this is a countdown timer, or I should say a cooldown timer, for the tower firing at the player. This basically, anytime the tower fires at a target, it starts a countdown timer, and it cannot fire again until that timer counts down to 0. Alright, let's add some functions under the second public section. Those are get health points. Pretty simple. It gets the current health points of the tower. We're going to add 2 functions that return bools. So bool is destroyed. Pretty simple. Is the tower destroyed or is it not destroyed? Bool can fire. Also self-explanatory, can the tower fire again? We're going to add 2 void functions. The first one is void fire. Basically fire at a target. And the next one is void hit. And this takes in a variable that is how much damage is incoming to the tower. So, after that, we need to add one more protected section. And this is going to contain one more function called destroy process. So, void destroy process. There we go. So that's all the code additions for the class called a defense tower. So all these additions work to the defense tower.h header file. Before we continue, I'm gonna build this project, and I'm just gonna click on that build button down here again. So that's gonna recompile the game and ensures that all of our code additions are recognized by Unity Editor. Alright, so once that's done, we can go ahead and add our next class. So I'm gonna right click in this empty space again. New C++ class. So this is going to be for the projectile that's fired by the defense tower. These projectiles spawn at some location, travel at some speed and direction, and they either hit something or they'll travel for some amount of time and then disappear after that. So this class also inherits from the actor class. Let's click next, and we'll call this projectile. Great class. So there is our projectile.cpp, which I'm going to put on the left here because we're going to add code to our header file. So hold on, it's rebuilding it again. So let that build again. Building 13 actions. Let that do its thing, and there we go. So now there is a projectile class. Let's go back to Visual Studio and file modification detected. The project Pangea has been modified outside the environment. Reload all. Now, let's add 4 things to our projectile. Under the public section, we're going to add 3 variables, and they're all floats. That's how fast the projectile is moving. That's how long the projectile lasts until it despawns. And that's how much damage the projectile deals when if it hits something. In the protected section, we're going to add another float. Underscore life counting down. So the projectile flies for some amount of time until it hits something, or the countdown timer counts down to 0 and it despawns. Very simple. Now we need to make one more class. So right click in this empty space again, new C++ class, And this is going to be for the player avatar. This one, however, inherits from character, which is a type of pawn that includes the ability to walk around. Actors are objects that can be placed or spawned in the world. Characters are pawns, but they have the ability to move around. So we'll select the character class to derive from, click next, and we'll name this class Player Avatar. Great class. Right, so now we have our CPP file, which I'm going to put to the left, so we can edit the player avatar.header file here. Oh, it's going to recompile it again. So let that do its thing, and after that we can go ahead and add some code to our avatar class. Reload up. Under the public section, we are going to add 5 variables. The first one is an integer. That's just the health points. The next 4 variables are floats. So float strength equals, we're going to set that to 10. The next one is armor. Float armor, we'll set that to 3. The next one is attack range, which we'll set to 6.0. The next one is attack interval, which we're going to set to 1.2f. Under the protected section here, we're going to add 2 variables, both prefixed with the underscore. So int health points for the player's current health points, and float attack counting down for the player's cooldown timer for attacking. Under the other public section down here, we're going to add 5 functions. Int get health points, ghoul is killed. So as you can probably tell, this sort of mirrors the defense tower, and we have the ability to fire at things, but we also have checks to determine whether, in the case of the defense tower, it can fire and check whether it's been destroyed, and for the player, check whether it can also fire and check whether you wouldn't say the player is destroyed, you'd rather say it's killed, but yeah, semantics I guess. So much like how the defense tower is destroyed and can fire, the player avatar is killed and can attack. We're going to add 2 void functions, void attack and void hit, and this takes in a variable called damage. There we go. Finally, we'll add another protected section here. Void die process. There we go. So those are all the code additions to our 3 classes. So player avatar, projectile, and defense tower. Now that's all done, let's rebuild our project again. Alternatively, you can go to Visual Studio and press Ctrl-Shift-B. That also builds the project. If you see in this error list down here, you'll see that there are several errors here. Ignore this for now. What's more pressing is the fact that we have several functions declared in the headers, but there are no implementations. Not yet, at least. So, with that, we can proceed to our next point of discussion, and that is the uProperty and uFunction macros. So, let's begin with the uProperty macro. So you add the uProperty macro before the declaration of a variable, and this exposes a variable to the Unreal Engine editor. A simple example would be something like this. You just add uProperty like it's a function and nothing within the parentheses. This example just exposes the variable to the Unity editor. But a complex example, such as this, we have a variable called speed, but edit anywhere indicates that the property can be edited in the editor's property window. The category specifies that it is under the params category in the blueprint editor window, and this meta here, which only contains one key, that specifies that the property name will display as SPD in the blueprint editor rather than speed. There are more specifiers as outlined in the book: blueprint assignable, blueprint authority only, blueprint read only, blueprint read write, category edit anywhere, and visible anywhere, and there are 2 metadata keys: allow private access and display name. Next one is ufunction. So we add this before the line that declares a C++ function. This changes how Unreal interprets and uses a function. And like with uProperty, it also has specifiers and metadata to interpret the use of the functions. With this example, we have a function called getHealthPoints. It's under the category of player avatar. It can be called by blueprint, and instead of being called getHealthPoints in the blueprint editor, it's called getHP. So here's a table of all its specifiers: blueprint callable, blueprint pure, blueprint implementable event, blueprint native event, category, and only one metadata key, display name. So we're gonna add these macros. We're gonna add these 2 macros, ufunction and uProperty, to our functions and properties that we have just written in our 3 header files. So let's begin with that defense tower. We're gonna add the uProperty macro to all 4 of these variables. So uProperty, and in parentheses, edit anywhere, comma, category equals tower parents. I'm just gonna copy this line and add a space here. Paste, paste, paste. Now I'm adding the space because it just looks neater that way. In the projectile.h file, we're going to do the same thing. uProperty, and in parentheses, edit anywhere, and category equals not tower params, but projectile params. So I'm just going to copy this line and paste, and paste. There we go. In the player avatar header file, once again, I'll do the same thing. uProperty, edit anywhere, category equals player avatar params. So I'll just copy that line and paste, 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 paste. There we go. All right. So the next step is we're going to add the ufunction macro to certain functions that we've written. Notice that there are no functions in the projectile.h header file that we need to add macros to, so we're only going to add ufunction to defense tower and player avatar. So let's go to defense tower.h. And we're only going to add these macros to certain functions. So for get health points, we're going to add the macro ufunction, and in parentheses, blueprint callable, comma, category equals, and in quotation marks, Pangea vertical character. It's called a pipe, by the way. And then defense tower, comma, meta equals, and then display name equals get HP. There we go. So that's our first ufunction macro. We're gonna add the ufunction macro to is destroyed and can fire. So let me just add some space, and I'll just copy most of this. I'm not gonna change the name. I'm not gonna change the display name, so all I gotta do is copy the first two parts of this ufunction here. Blueprint callable and category equals Pangea defense tower. And then I can just copy that same line and paste it underneath can fire. We do not need to add any macros to fire and hit. Now we can start to add code to the defense tower's CPP file. So I'm going to expand this side here, and then we can add code. So I'm going to add these functions after all of these functions that were pre-made here. So it is int a defense tower double colon get health points, and it's going to return underscore health points. The next function we're going to write is bool a defense tower double colon is destroyed, and we're going to return in parentheses underscore health points is less than 0.0 f. So no, my bad. That says return health points is greater than 0.0 f. So it's considered destroyed when that condition evaluates to false. That means it ran out of health points, so it should be destroyed. Then we're gonna add another function here, bool a defense tower double colon can fire, and like the previous function, it's gonna return a bool. It's gonna return, and then parentheses underscore reload counting down is less than or equal to 0.0 f. There we go. So those are the function implementations for here. And with that, okay, let me save all. So I'll click this button here that looks like two floppy disks stacked on top of one another, and there we go. I'm gonna build this again just to make sure Unity, or rather Unreal, knows that these changes can be recognized. Okay, now we're gonna add the ufunction macro, the three functions in the player avatar.h file. I'll just cheat here and I'll just copy the macro for get health points from defense tower and just paste it right before the line for get health points for the player avatar. However, the category should not be defense tower, but rather Pangea player character. And much like with the defense tower, it's gonna have the display name get HP. I'll add a space here, and I'm gonna copy these first two parts again. And that's gonna be the macro that we add for is killed. So U function blueprint callable category equals Pangea player character. I'll copy that whole line and paste it before can attack. There we go. Right, so that right there is our code in the header file. Next thing we're going to do is we're going to add 3 functions to the player avatar.cpp file. What I'll do is I'll cheat a little bit and I'll copy these 3 functions and just modify their names. So these are not functions in the defense tower anymore, they're functions in the player avatar class. So I'll just copy a player avatar and paste it here, here, and here. So a player avatar : get health points. A player avatar : is killed. And a player avatar : can attack. Okay, one other change I need to do is there is no variable called reload counting down, rather it's attack counting down. So I'll just replace the word reload with attack. So these functions are the player avatar equivalent of these functions. With our functions and properties tagged appropriately, now we can start to add components to them. To the projectile and defense tower classes, we're going to add 2 components. The first one is a static mesh. This is so the actor can be visually represented in game, and a box collision component for collision detection. We're going to add these to the A projectile and A defense tower classes. So we're going to go back to the header files here. Move this out of the way. And in the header file, for both projectile.h and defense tower.h, we're going to add 2 lines to our boilerplate code. These lines must be added before this projectile.generated.h statement here for the projectile header, and defense tower.generated.h in the defense tower. So I'll just write it once and then I'll just copy paste it to the other. So include, and then quotation marks, components / box component.h, and include component / static mesh component.h. There we go. And then I'll copy and paste these 2 lines from projectile.h to defense tower.h. There we go. Okay, now we're going to add a few more properties to the defense tower, and it goes under generated body here. So that generated body macro, after that we're going to add private, and we're going to add a ubox component star underscore box component. We're not done yet. We also have to add a macro, and that is uProperty, and then within the parentheses we're gonna add in visible anywhere, comma, blueprint read only, comma, category. Okay, this should be uProperty, all caps. There we go. Category equals tower component, comma, meta equals, and then the parentheses, allow private access equals true. So this is a long line, but just the entirety of that one. uProperty, visible anywhere, blueprint read only, category equals tower component, meta equals allow private access equals true. I forgot an extra parenthesis there. So ubox component star box component. It turns out I forgot to copy another line here, and that is components slash box component. So that's why the editor is reporting an error. It doesn't know what ubox component is. Now that I've copy pasted that include line here, it should know what ubox component is. And there we go. It just changed color. So now it works. I'm gonna copy these 2 lines of code and paste it down below because we need this other macro again, but not for another ubox component. It's gonna be for a uStaticMesh component. uStaticMesh component star underscore mesh component. So uProperty visible anywhere, comma blueprint read only, comma category equals tower component, comma meta equals allow private access equals true. There we go. We also need to add getter functions for these in here. So right after the 2 protected variables here, I'm gonna add another public here. Maybe we don't have to, and we could just merge these 2 sections together, but I'll just do it like this. I'm gonna say force inline ubox component star get box component parentheses const, and then return underscore return box component. There we go. I'm gonna copy that function and paste it because we need 2 getter functions. The second one is gonna be for uStaticMesh component star and get mesh component. So I'll just replace the word box with the word mesh. And instead of returning box component, it returns mesh component. There we go. So these are getter functions that we've just added to our header here. So what's this force line doing? So that is another macro that forces the compiler to insert a copy of the code instead of calling the function by its address. Functions like these that are small and called frequently are preferred to declaring them as inline functions to reduce the function call overhead. And the const keyword, if your call from C++ programming, the const keyword prevents the function from changing its parameters or mutable class members. So now that we have a box component and mesh component in our defense tower, we must initiate them in the defense tower constructor. So all these changes that we have made to our defense tower.h, now we have a box component and mesh component variable, but we need to initialize them in the defense tower constructor now. So let's go to the constructor for defense tower.cpp here, and we're gonna add a few lines of code after this primary after tick line. So I'll add a few empty lines here, and I'm gonna say underscore box component equals create default sub object. In angle brackets, I'm gonna type in ubox component, and then I'm gonna pass in parentheses text in all caps, and in parentheses again box collision. I'll say set root component, and in parentheses underscore box component. The next line is underscore mesh component equals create default sub-object. In angle brackets, I'm going to say use static mesh component. And in parentheses, text. And in parentheses, static mesh. And then for the last line, I'm going to say underscore mesh component arrow operator set attachment box component. So we just added 4 lines of code. What did it do anyway? Okay, so the box component is the root component for the defense tower, and the mesh component is a child of that box component. So that's what just happened here. We not only created a box and mesh component, but we set up a parent-child relationship between the box component and the mesh component. So the mesh component is a child object of the box component, and the box component is the root component. So yeah. Let's go ahead and rebuild that project. So I'm just going to click the build button here. So it's going to compile all of our changes, and we should see it complete pretty soon. Building linked and finished. Okay, now we can make blueprints from these 3 classes. So the goal of blueprints is, as I mentioned, it's a node-based alternative to programming, which is meant to be friendly to non-programmers, but it's still versatile to programmers in that by using a balance of C++ code and blueprints, we can strike a balance between performance, complexity, and flexibility. Relying exclusively on C++ sacrifices the flexibility of blueprints, but utilizing blueprints for simple things allows us to more easily tweak and iterate our code without actually having to go back and change our code. Okay, so how do we make a blueprint? Alright, so to do that, let's find our blueprints folder in the content browser here. So all, content, top down, expand this subfolder, and there is our blueprints folder. There are currently 2 blueprints in here right now. What we want to do is click this empty space, and we want to make a blueprint class. So create basic asset blueprint class, and expand all classes, and let's search for defense tower. There it is. So click on defense tower, select, and we want to name this blueprint BP underscore defense tower. There we go. We're gonna repeat that process for the player avatar and projectile. So right click, blueprint class, search for player avatar, select. Call that BP underscore player avatar, right click, select blueprint class, search for projectile, select that class, select, name that blueprint BP underscore projectile. There we go. Now we just made 3 different blueprints for our 3 classes: BP defense tower, BP player avatar, and BP projectile. And we can open one of these too. So let's open up the defense tower by double clicking on it, and this is gonna open our blueprint editor for the defense tower. So remember what I said about the box component and mesh component having a parent-child relationship? Well, there it is in the components tab over here. The box component is the root component, and the mesh component is a child of that box component. If we go to the right here in this details tab and type in tower params, we can see all of our tower params here. So health points, shell defense, attack range, reload interval. The point of exposing these variables is so we don't have to go back into code, rather we can just edit it in the blueprint. We can then click on this event graph, and here we have our blueprint editor. So we can just right click to create a new node. So for example, I can just type in for example, type in defense tower. I can see functions for can fire, get HP, and is destroyed. So we can use this to add nodes to our blueprint for functionality for our defense tower. So just typing in defense tower pulls up these three functions: can fire, get HP, and is destroyed. Alright, so that's enough on the blueprint editor. We are almost done here. So the last things I want to talk about here are the Unreal Gameplay Framework classes. So there are 4 classes: player controller, game mode base, game state, and game instance. When we created this project, let's go back to that folder full of classes. We made player avatar, projectile, and defense tower. But when we made the project, there were Pangea character, Pangea game mode, and Pangea player controller. So so those 3 classes were made by our project when we created the project. 2 of those classes derived from player controller and game mode base. There are 2 other base classes that we need to add manually. So those base classes are game state base and game instance. So as I said, when we first created the project, Pangea game mode and Pangea player controller were base classes that inherited from player controller and game mode base. They were automatically generated, but now we need to add 2 more classes. Those classes are, we're going to call the first one Pangea game state. I am going to click all classes and search for game state base. I'll click that, click next, and I'm going to name this Pangea game state. Create class, and there we go. That is a brand new class that just made. I'll put the header to the right. Reload. And the next class after that. Okay, first we need to wait for this to finish up, and there we go. Now we have 7 classes in our folder here. We need to add 1 more. So we just made Pangea game state. We need to add Pangea game instance. Right click, click new C++ class, click all classes. We're gonna search for game instance. Select that, click next, and I'm gonna call this Pangea game instance. And click create class. There we go. Now we wait for the editor to compile all that. Okay, so I guess the question now is, what do these classes do? Okay, so let's begin with the player controller class. This class encapsulates commonly used variables and functions needed for player controls. So this class is for player controls. By decoupling it from the pawn class, we can more easily work with player controls separately from the pawn class. It's recommended that you have a class that derives from player controller. So, this class can be considered an invisible pawn that bridges the player and the controlled pawn or character. And as you said, by decoupling the player's pawn logic from player control logic, it makes it easier to let the player possess different pawns or characters. When you use the player control class, consider having it take care of player receiving and handling player input, moving and rotating the controlled pawn or character, changing the state of the controlled pawn or character, and manipulating the camera views. For the game mode base class, you need the game mode object for all Unreal projects because it stores game information and settings like the starting level of the default pawn character, the player character, and so on. By extending it, we can add more gameplay info and rules in the child class, such as, say, flags that allow pausing the game, playing cutscenes, enabling tutorials, level transition conditions and processes, spawn locations for multiplayer games, how many players do you need to start a game, and the conditions to end a game. For online games, this only exists on the server side. For game state, this is usually used to store the dynamic gameplay information. Extending it allows us to store more information, such as time elapsed since the start of the game, total scores, waves of enemies, enemy positions for the minimap, and countdown timer. For online games, this exists on both the server and the client. The game state's object's information can be synced between the server to the clients. And for game instance, it's a high-level manager that represents the instance of a running game. By extending it, we can put important local gameplay variables into the child class. Unreal games are built on a multiplayer game framework, even if it's a single-player game. Therefore, assume that your game is an online game and determine whether those global variables are necessary on a server. If not, then have it be a variable of the game instance class instead. So with these 4 classes containing such important information, how do we get that information? So, we ought to know how to get that information. So, let's examine this code snippet to see how we can get that information. All you gotta do is create a uWorld pointer, and on the right hand side we call getWorld. To get, say, the player controller, we just say world and then the arrow operator and call getFirstPlayerController. That lets us get a reference to, it gets us a pointer to the player controller. We can do something similar for the game mode, the game state, and game instance. So world arrow get off game mode, world arrow get game state, and world arrow get game instance. However, you are likely going to be writing derived classes, so some of these are the wrong data type. So to fix that, we need to cast them from the base classes, because Unreal will work in terms of the base classes. For us to work with the derived classes, we ought to cast them from a pointer type for the base class to a pointer type of the derived class. And we use the cast function for that. So, right here's the function signature for the cast function. The standard functions can only return base type results, so it's up to the programmer to convert them to the specific type. So we use the cast function, which casts a pointer of type from type to a different type of to type. And here's a code snippet that shows an example of that cast function being used. So a Pangea player controller, we're gonna take our player controller and cast that to type a Pangea player controller. You've probably dealt with casting before, where, for example, you had a integer variable that you wanted to cast to a float. So, for example, you had code that would have looked like this. You probably would have had code that looked like this. So I'm just gonna write some random code here. So So if you wanted to cast this example variable to a float, you would say something like this. So that's an example, but we have a special function for casting these. So we have a special function for casting these pointers from the base class type to the derived class type. So let's look at a summary of what we've done so far. We looked at several base classes. We were introduced to the following gameplay framework classes: a actor, a pawn, a character, a player controller, a game mode base, a game state base, and game instance. And by extending these classes, that is, we write new classes that derive from them, we can create needed elements for developing new games. We are also introduced to the uProperty and uFunction macros. These make actor properties and functions recognizable and work together in the engine. We also made 3 classes: Defense Tower, Projectile, and Player Avatar. We learned how to rebuild our project, which ensures that any changes to our game are properly integrated into our game. We also learned how to make blueprints from them. We also looked at the cast function, which converts base class pointers to the appropriate derived class pointers. So in the upcoming chapter, we are gonna look at configuring the player avatar. So that's gonna be the next chapter. I'm gonna do my best to get this next video out as soon as possible. So with that, that's gonna be it for this first video, and yeah, I'm gonna do my best to get us through Unreal as fast as we can, because we are at the tail end of the semester. So in terms of your Unreal projects, I understand that not everyone has a beefy computer. Beefy how? For reference, this computer is a 5800X and 4080 Super combination, and 32 gigabytes of RAM, and yeah, that's a lot of memory. And okay, a whole bunch of the memory just got deallocated. But my point is, not everyone is gonna have this powerful a computer, and because of that, I have made the decision to make Unreal projects be done in a group. I'm gonna have to talk. I'll likely have to talk to the class about how specifically we're gonna do that. So, is it gonna be the same game programming groups as before, or is it gonna be a different set of groups? That's something I'm gonna have to ask the class about. So, with that, I'm gonna end the video here, and in the coming weeks, we're gonna also discuss your final project as well. So, I have for the next video, which I'm gonna have to make the next video, chapter 6, sometime this week, just to make sure that we are on course. Because so far we wrote a few basic classes, but we didn't really do much of them. So, but hopefully in the next few chapters, we're gonna really flesh out our classes here. So it's gonna take several chapters to get. It's gonna take several coding sessions to get through everything, but hopefully we can make something substantial at the end of it all. Okay? Okay, so that's gonna be it for this video, and if you have any questions, feel free to let me know, and we're gonna go from here and look at the next chapter, setting up the player character. Alright? Okay. Have a good one, and see you next video. Bye.